Q2b is another radical equation that we're going to solve algebraically. This one is a little bit more complicated just because we have two radicals in the same equation, and we already have the square root of 12x plus 1 isolated, so I'm going to leave that there. So it's the square root of 6x minus 11 plus 4 equals the square root of 12x plus 1. Our goal is to isolate one of the radicals, and that one already is, so now I'm going to square both sides to try to eliminate one of the radicals. Over here we're squaring a binomial, which gives us a trinomial. So when I square the argument of 6x minus 11, the square root, that is just 6x minus 11. The squaring will undo the square root. Then I got to double the outside inside. So I have to take 4 times the square root of 6x minus 1, or 6x minus 11, and then double it. So that's going to give me plus 8 of those square roots of 6x minus 11. And I'm going to square the last. 4 times 4 is 16. On the other side, I'm squaring the argument of 12x plus 1, and that squaring will undo the square root, so we just have 12x plus 1. So that's after my first round of squaring. So now we're going to come back, and we're going to use the same idea. We want to isolate this radical the best that we can, so we're going to be collecting some like terms first. So I'm going to have 6x plus 8 times the square root of 6x minus 11, and then 11 and 16, that simplifies to plus 5 equals 12x plus 1. Now I'm going to get down to where I can isolate this in the next step. So 8 times the square root of 6x minus 11 equals, moving the 5 over, that is going to give me a negative 4. Moving the 6x over, subtracting 6x from 12x is 6x. Now we said we can keep this 8 over here, and I just can keep it over there because 8 does not go into 6 and 4 evenly, so I don't want to move that over there. As long as it's just being multiplied by the radical, it's not that big of a deal when we try to square. So I'm not going to move the 8. I'm not going to completely isolate that radical because it's easier if I don't make fractions over here. So I'm going to square both sides again. In order to undo that radical, a square root, I'm going to square both sides. Now I'm squaring a monomial over here. That's going to be 8 times 8, which is 64, and then I'm going to square the square root of 6x minus 11, which gives us 6x minus 11. On the right side, we're squaring a binomial, so that means we're going to get a trinomial. So I got 36x squared. I'm going to take the outside inside multiply, which is negative 24, and then double it, which is a negative 48x, and then plus 16. We've got a little distributing to do on the left-hand side, so over here we're going to have 6 times 64, that's 24, clear the 2, 384x, and minus 64 times 11. 64 times 11, that one's a little bit more straightforward, 704 equals 36x squared minus 48x plus 16. Again, we're going to get down to where we recognize that we have a quadratic equation, so I want to get one side equal to 0. So 0 equals, I'm going to pull over the 384x over here with the negative 48. So that means we're going to subtract 384 from 48. And if we do that, we get a negative 432x. And I'm also going to move the 704, so I'm going to add 704 onto the 16, which would give us 720. So this is the quadratic equation that we need to solve. One of the things that I kind of looked at and tried to recognize is there any number that divides into all 3 of those numbers evenly? And lo and behold, 36 is a number that divides evenly into all of them. So I'm going to choose to factor that out first. And 36 goes into 432 12 times, so 12x, and 36 goes into 720 20 times. So that made the numbers a little bit more manageable, and I was pretty confident that I could solve that by factoring rather than using the quadratic formula. And many of you just chose to use a quadratic formula from here, which would be fine. You'll get the same results. So 0 equals 36 times factors of x squared are x and x. The signs have to be the same. They both must be negative. Factors of 12 or 20, that'll give you 12. 10 and 2 are your numbers at work. What are the only values of x that can give you an answer of 0? According to our zero factor theorem, it's just a positive 10 and a positive 2. So these are our possible answers that I want to test. This 36 is nothing more than a constant. It can impact zeros of the function. So I want to come back and test 10 and 2 back into the original. So I'm going to grab the original, pull it over here, and we're going to test these two answers, 10 and 2, to see if they work. So Using 10, 6 times 10 is 60, 60 minus 11 is 49, the square root of 49 is 7, and 7 plus 4 is 11. So on that side I got 11. 12 times 10 is 120, plus 1 is 121, so the square root of 121, that's 11. So 10 works. I want to include that in my solution set. And I also want to try out the 2. So I'm going to take 6 times 2. 6 times 2 is 12. 12 minus 11 is 1. The square root of a 1 is 1. Plus 4 is a 5. On the right side, I got 2 times 12, which is 24. Plus 1 is 25. So we got the square root of 25, which is a 5. So these both work. So I want to keep both the 10 and the 2. Obviously, of the two radical equations, that's the one that's a little bit more involved. It's the one you have to be very meticulous and careful that you don't make a mistake along the way, and keep track of all your signs and your numbers and so on. So there's your second radical equation.